This is Dr. V. Gauru Shankar Rao, Department of Mathematics, St. Joseph College for Women. Now we discuss about differential equations. In this paper, the chapter is differential equations of first order but not of first degree. So here one more name also is there, differential equations of first order higher degree also. Let us see differential equations of first order but not of first degree. In this previous models, we discussed about first order and first degree equations. So in these methods, you can use Lebesgue, Bernoulli's, Exarch. These methods are applied first order, first degree equations. But here you can solve first order, but it is not a first degree. In that time, they can develop the four methods. One is the soluble for P, soluble for X, soluble for Y, Claret's equation. So by using these four methods, you can solve first degree, differential equations of first order but not first degree. So most of them here you can use P equal to dy by dx. Now we can see the definition of ordinary differential equations. A differential equations which involve only one independent variable and different coefficients with respect to it are called ordinary differential equation. So here one more thing, remember that only the single independent variable is involved in differential equations. These type of equations is called as ordinary differential equations. For example, you can see the dy by dx equal to x square minus 1. Here x is the independent variable, y is the dependent variable. X is only the single and independent variable. So that's why it is called as ordinary differential equation. Now we can see the order of a differential equations. The order of a differential equation is the order of the highest order derivative occurring in the differential equation. In the derivative is involved highest order. It is called as order of a differential equation. Now we can see this equation d square y by dx square minus y equal to 2. What is the order? This is the 2 is the order. Now we can see the degree of a differential equation. The degree of a differential equation is the degree of highest order derivative power is called as degree. Highest order power. Here you can see this equation dy by dx whole square minus d square y by dx square plus y equal to sin x. Here what is the degree? Degree is the 1. Why? Because of, so in this equation highest order is d square y by dx square. The 2 is the order. Here there is no power. There is no power means what is the degree is the 1. So the next definition is formation of a differential equation. How we can formation of a differential equation? Differential equations are formed by elimination of arbitrary constants. So to eliminate two arbitrary constants, we require two more equations beside the given equation, leading us to second order derivatives and hence a differential equation of second order. The simply, so here the two constants is given, you can apply the derivative on 2 times, automatically you got the second order differential equation. Now we can see the example y equal to e power of x into a cos x plus b sin x. Here a and b are the constants. Now we can apply the derivative first and second, or automatically the constants should be eliminated. The final you got the d square y by dx square minus 2 dy by dx plus 2y equal to 0. Before I told these are the four methods. What is that? Soluble for P, soluble for X, soluble for Y, Claret's equation. My assumption, soluble for P means how you can identify the question is it is a soluble for P or soluble for X or Y or Claret's equation. So before you can identify the problem, so which type of model it is, a p, x or y. So for example, the problem is given solvable for p. You can identify that any two variable powers are equal. So each and every equation they can involve p and x, y variables. Now we can observe these three variables, any two powers, any two variable powers are equal, it is solvable for p problem. The most of them 90% problems, it is based on this analysis. For example, solve yp square plus x minus yp minus x equal to 0. Now we can observe this x into here that the two variables should be equal. At the same time, solvable for x. Comparing to x and y powers, then y power is more than to x. The symbol you can observe this x powers is the less comparing to y powers. So in that time, this problem is solvable for x. Soluble for y also the same. Comparing to x and y powers, then x power is more than to y. The most of the problems they can treat it as this type of analysis. You can identify solvable for p related problem or x or y. It is easily identify that. Let us see equations solvable for p. The given differential equation p power of n plus a1 into p power of n minus 1 plus a2 p power of n minus 2 plus so on a n minus 1 p plus a n equal to 0. This is look like as given differential equation. So how we can solve this equation? After that we can use factorization. So like p minus f1 of x comma y, p minus f2 of x comma y. Like you can change the given equation as like factorial form. So after that you can equating to 0. So then you can use p means what is the dy by dx. Now we can apply that variables or variable separable, then you can integrate, automatically got the answers. So where c1, c2, cn are arbitrary constants, we can write as c1 equal to c2 equal to cn equal to cn. So that solution is, how we can write the solution is like phi 1 of x comma y comma c. The second solution they can write it as phi 2 x comma y comma c. So for example, got the ordered solution they can write like this. Let us see the problem. Solve p square minus 5p plus 6 equal to 0. So this is the given problem. How we can solve this problem? Given equation is p square minus 5p plus 6 equal to 0. So this equation you can write as a factorial form. So how we can write the factorial form? So for example, p square into 6, it is called as 6p square. Now we can write minus 5p, it can be treated as minus 3p into minus 2p. So after that minus 5p replaced by minus 3p minus 2p, then you can take the p is the common and minus 2 also common. You got the two terms. One is the p minus 3 into p minus 2 equal to 0. So p square minus 5p plus 6 equal to 0. It can be written as p minus 3 into p minus 2 equal to 0. Now we can separate the two equations, p minus 3 equal to 0 and p minus 2 equal to 0. So already know that p means what is that dy by dx. So minus 3 equal to 0. Then another equation p replaced by dy by dx minus 2 equal to 0. So after that this first equation dy by dx equal to minus 3, you can shift the right side, you got the plus 3. The second equation dy by dx equal to minus 2 also, you can change the right side, it can be read as 2. Now you can apply the variable separable dy equal to 3 into dx and dy equal to 2 into dx. You can take the integrating on both sides, we get. So dy, that integration and derivative is the cancel, you got that y. So the 3 is treated as a constant. What is the differentiation with respect to x? Integration is the x. Then you can apply the plus c. At the same time, the second equation after integration you got y equal to 2x plus c. Therefore, the general solution is y minus 3x minus c, y minus 2x minus c equal to 0. Then you can see problem 2. Solve x square p square plus xyp minus 6y square equal to 0. So before I said, now you can check any two powers is equal. Now we can say this p square and p is the p cube and 3. x square and x also the power is the 3. The both two powers is the equal. The most of the 90% is it is you can check like this. So given equation is x square p square plus x by p minus 6y square equal to 0. So again you can by using this equation you can change. How we can change? Now we can observe this xp is the common term. Once we can take xp is the common, what is the remaining? Xp. Here xp is the common, the remaining term is the 3y. Let us see this. The second minus 2y is the common. The remaining xp plus 3y equal to 0. After that, outside of the variables is xp minus 2y. The common variable is the xp plus 3y. So, after again you can write as xp plus 3y equal to 0. xp minus 2y equal to 0. So, already know that. P means what is that? dy by dx. So x into dy by dx plus 3y equal to 0, x into dy by dx minus 2y equal to 0. You can use variable separable x dy equal to minus 3y dx, dy by y equal to minus 3 by x dx. The same process you can apply the second equation also. It can be written as dy by y equal to 2 by x into dx. After we can apply integration log y equal to minus 3 log x plus log c1. So log y minus 3 log x we can shift the left side. It can be written as log x cube equal to log c1. It is look like log a plus log b formula. What is a log a plus log b means? Log a into b, like that. Log y into x cube equal to log c1. Both sides you can cancel the log. You got x cube y equal to c1. After that c1 you can shift the left. X cube minus x cube y minus c1 equal to 0. The c1 or c you can treat it as the both are the constants. You can write like that, no problem. The second equation I can apply the integration log y equal to 2 log x plus log c2. So why you can take the c2 means already c1 is involved. So that's why you can take the constant c2. So log y equal to 2 log x, it can be written as log x square plus log c2. So this log x square log y you can shift the left side, automatically you can write that log y by x square equal to log c2. So then again the log both are the cancel, you got y by x square equal to c2. So then y equal to c2 x square, again you can shift the left side, y minus c2 or c the both are the same, y minus x square equal to 0. After that you can write the both solutions like x cube y minus c into y minus x square equal to 0. This is the required solution of the given equation. Now let us see problem 3. Solve p cube plus 2xp square minus y square p square minus 2xy square p equal to 0. So this is the given equation. So now we can see the solving for p. Now we can observe each and every one p is involved. So that's we can take the p is the common. After we can take the p is the common, p cube it can be written as p into p square, then p into 2xp minus y square p minus 2xy square. So then p equal to 0. The second bracket equation it can be written as p square plus 2xp minus y square p minus 2xy square equal to 0. P means how we can write dy by dx equal to 0. This is the first equation. The second equation again you can take the p is the common. After p common, p into p plus 2x minus y square is the common, you got p plus 2x. Then the first equation dy by dx equal to 0. Now we can apply the integrating on both sides. The derivative integration is a cancel, got that y. So the right side there is no variable, that's why we can treat it as a constant. So the first solution is y equal to c1. So y equal to c1, how we can write y minus c1 equal to 0. c1 it can be written as c, y minus c equal to 0. So again you can see the second equation, p plus 2x is the common term. So that's you can write the p plus 2x is the 1. Outside of the bracket terms, what is the p minus y square? It is like factorial. P plus 2x into p minus y square equal to 0. Again you can equal to 0. P minus y square equal to 0. P plus 2x equal to 0. So p means what is that? dy by dx minus y square equal to 0. So dy by dx equal to y square. Variable separable, you can apply the variable separable 1 by y square into dy equal to dx. So p means what is the dy by dx plus 2x equal to 0, the second equation. Dy by dx, it can be written as equal to minus 2x. You can apply variable separable. Dy equal to minus 2x dx. Integrating on both sides, we get minus 1 by v equal to x plus c2. So x plus 1 by y plus c2 equal to 0. So x plus 1 by y plus c equal to 0. The second equation integration is y equal to minus 2 into x integration x square by 2 plus constant. So the 2 is the cancel. The remaining minus x square, it can be written as y plus x square minus 3 minus c3 equal to 0. This is y plus x square minus c equal to 0. Now you have the three solutions. One is the y minus c. The second is the x plus 1 by y plus minus c. Sorry, plus c. Y plus x square minus c equal to 0. So therefore, it is the required solution of the given equation. Now we can see problem 6. Solve x square p cube plus y into 1 plus x square y into p square plus y cube equal to 0. So this given equation is the solving for p. So again you can observe that each and every p is involved, every term p is involved. That's why you can take the p is the common first. So once you can take the p is the common, you got x square p square plus y into 1 plus x square into y p plus y cube equal to 0. The first you can equating p equal to 0. This is the one equation. P equal to 0. P means what is the dy by dx equal to 0. Again you can apply the integrating on both sides. You got y equal to c1. It can be written as y minus c1 equal to 0. This is one of the solution. So now we can see the second equation. What is the second? X square p square plus y into 1 plus x square into y p plus y cube equal to 0. Now we can simplify this. X square p square plus yp plus x square y square p plus y cube equal to 0. So now we can take x square p is the common. You got p plus y square plus y is the common. P plus y square equal to 0. Now we can see the bracket term is the common, that is called p plus y square. The outside of the bracket is the x square p plus y equal to 0. Let us see this equating p plus y square equal to 0 and x square p plus y equal to 0. You have the two more equations. Now again p replaced by dy by dx, then you can written as equal to minus y square. Use variable separable. So what is the variable separable after dy by y square equal to minus dx. And here also p replaced by dy by dx. X square into dy by dx equal to minus y. So variable separable dy by y equal to minus 1 by x square into dx. On integrating both sides, you got minus 1 by y equal to minus x plus c2. So minus 1 equal to minus x into y minus c2 into y. So xy plus c2y minus 1 equal to 0. It can be written as xy plus cy minus 1 equal to 0. The second equation it can be written as log y equal to 1 by x plus log c3. So log you can shift the left side, log y minus log c3 equal to 1 by x. So it is look like log a minus log b formula. What is the log a minus log b? Log of a by b. So the same time it can be written as log y by c3 equal to 1 by x. Now we can cancel the logarithm. You can apply the exponential on both sides. So exponential log is a cancel. You got y by c3 equal to exponential of 1 by x. Again you can check the left side, it is the division. So that's you can write y into e power minus 1 by x equal to c3. So therefore y into e power minus 1 by x minus c3 equal to 0. Again c3 it can be written as constant. Y into e power minus 1 by x minus c equal to 0. We have the three type of solutions. One is the y minus c. The second one is the xy plus cy minus 1. The third one is the y into e power minus 1 by x minus c equal to 0. So this is the required solution of the given equation. Now we can see that practice problems. So the 5 problems is there. These are the practice problems. You can do that. Thank you all watching this video solvable for P, first order higher degree equation. Thank you.